Hi, and welcome to this lecture on debugging and testing. In this lecture, we are going to learn about what debugging and testing are. We're going to learn about how to use them, and we're going to learn about the common errors that are associated with them. Let's open up the script editor and get started. In your viewport, if we just click, then press and hold the spacebar, go over to panels, click, drag down, go to panel, and then to script editor. And I'm going to try and explain this to you without boring you too much. But the caveat to that is that I think this is probably one of the most important sections now. So I can't believe we're nearly getting to the end. So congratulations on you getting this far. And I hope that I've been able to give you some wisdom. But I think this is probably, I would say, the most important lecture of all of them. So what is debugging? Let's start here. So debugging is the process of finding and fixing errors, okay, or bugs in your code. Okay, in Python, you can use various tools and techniques to debug your code. Debugging in Maya is generally not so bad as long as you are showing the stack trace and the line numbers in errors. Okay, so up here in history, make sure these are both ticked on, always. Okay. So this is mainly because if you have thousands of lines of code and you are searching for an error without being told what it is, okay, or where it is, it's going to be hard to find. It'll literally be a needle in a haystack. Well, not literally, but it will be, okay, metaphorically a needle in a haystack, okay? And then you could have multiple haystacks. You've got multiple modules with thousands of lines of code. It's just going to be a nightmare. So, but that's the good thing about Maya and mainly Python is that you are in 99% situations, Maya will tell you exactly where the error is, okay, and it'll tell you what type of error it is as well. And now it even gives you that little arrow on the screen to point it out for you. So, in the last 10 years, things have come a long way. Here's some simple ways to debug your Python scripts in Maya. You can use print statements, and you can insert print statements at different points in your script just to check the values in the variables. Or to see a certain part of the script that is being executed, you can put a print statement right there. I suggest that you iterate the print statements as well. So this means that essentially every print statement you put in, you start with 001, then do a comma and then a comment or your variable essentially that you're putting in. Essentially adding a number will just kind of make it easy for you to search for that. So obviously you're not going to have, say, hashtag or like a forward-facing arrow and then 001 throughout your code. So it means that you can then just search back to it if you've been scrolling around. And obviously, if you've got iterations in your print statements, if you're jumping between 5 or 6 functions over 4 or 5 modules, then again, this makes it very easy for you to find it when jumping between all of this code. Let's have a little look here. We'll start off with a nice little simple function. So we've got our Maya commands being imported as M. Okay, we're going to create a function that creates a sphere. It doesn't take any arguments. We're just going to keep it all simple. And we're just going to create our sphere and return it at the end. So we could even do object equals, and we're going to get that sphere back. So let's run that. Let's run this code. Let's just highlight everything and run. Nothing's been created. And we've got an error, which is, again, highlighted in red down here for us. Now, what does this error say? Okay, we've got an invalid flag, NM. It says for us on line 8 specifically, that's where our error is. So right here, line 8. Okay, we've got our invalid flag, NM. So pretty simple. If we go through and we look at the Python docs, so we'll type in our search window, Maya Python sphere. And generally the first one that will come up, okay, if you type in Maya Python and then the command you're running, which is actually incorrect, we're typing in polysphere. Okay. We'll type in polysphere. Okay, we literally are going to get all the information now. We've got Mel and Python up here in the top right, but what we are looking at is obviously the Python. So we can go down and we can see everything that we're looking at. So N, okay, name, that is where we're going wrong here. Great, it's easy to see, and we've got some examples here. See, we get the commands here as a standard, but again, I don't know why you'd import Maya commands as commands. It doesn't seem to be saving us much, so that's why we do M. Save us those three characters there. Just, again, saves us a little bit of time. Cool, so we found our error. So we just need to put this being N, and then we can go rerun everything. Let's just highlight all and press Command and Enter. We have got our sphere down here. Our object, our variable, has sphere geo saved to it. We've named up here. All right, we've got everything we need essentially here. Brilliant. It's giving us all our data and information. Great. So essentially we've debugged there. We didn't need to add any prints to that, really, did we? But as you're going through it, what you can do, again, make sure that you're getting the information you want. You can go through and say, okay, sphere. Let's have a look. Again, shouldn't really be using a keyword here because you can also do m.sphere, but again, that comes after the Maya dot notation, so it doesn't really matter so much. So let's do this all again and print, okay. All right, and so we printed out sphere geo. This is what we're returning as well and getting back as our object. So let's have a little look more. Let's print a little bit further and get a bit more information. We have just typed out and we've got print and we've got creating sphere, which then goes through and we create our sphere. We know where our error is, so we'll remove this and fix this. And then we'll go for sphere created and we've got the name of the sphere being added. All right, let's go for it again. Let's delete our sphere in the screen. I literally just did that by highlighting and pressing delete. But I have highlighted all in the window and I've pressed Control and Enter. And now what we're getting is creating sphere. Oh, let's keep equal spacing. And then we've got sphere created, sphere geo. So again, nice simple way of debugging. And obviously if we still have our error occurring, what we get is, okay, let's clear our window at the top for a nice clear output. Oh, okay, well we get the first print which says creating sphere, but obviously then line 9, we've got our error in create sphere. So in create sphere, the create sphere is the name of our function. Okay, and it's saying on line 9, we're having our error. So again, being told exactly what to look for in that line within create sphere and on line 9. Where is NM? It's right there. Okay. So again, this is basically all you would do. Okay. If you were debugging, you would just set some print statements up, make sure you are outputting all the information you need, doing a print statement, maybe a different section. So if you had about 10 or 8 different commands running within a function, then maybe you set 7 or 8 prints going through that at different stages where something's happening. Maybe you assign some variables or you just put some names into some variables to start with some strings. Maybe you print all those out afterwards. Okay, so that maybe just needs one print. And then maybe you start running functions in the next, so you start putting each one after a function. Again, it's just another way of you easily being able to see everything that's going on. Nice and simple. All right, now let's go back and talk a little bit more about some more in-depth methodologies. So using the script editor in Maya has allowed us to run and debug the scripts. We've used the print function, as we've mentioned, and we've done this above and below our functionality to make sure that we print out some useful information, letting us know before and after the functionality has occurred. But we can also use error, open parentheses, and warning, open parentheses. And these are functions that print out an error and warning messages, respectively. So using external Python IDEs, you can write and debug your Maya Python scripts using external Python IDEs like PyCharm. Okay, to use external IDEs, you'll need to set up your Maya environment to use the same Python interpreter. Once you've done that, you can write your script in the IDE and use Maya Python, the Maya Python API to interact with Maya objects and data. To debug your script, you can then set breakpoints in the IDE and use debugging tools provided by the IDE. For example, in PyCharm, you can use the debugging panel to step through your code and inspect variables and more. That's why we might go into a little bit more in PyCharm later. Let's move on to our next section. Testing. Okay, sorry to enlarge that window there. I just literally had my mouse over the window and then just tap on spacebar. And you see, it'll go back to being one window highlighted. Let's talk about testing now. Okay, this is definitely where we get far more important. Okay, this I would say is probably the most important thing for you to spend time doing, make time doing, and force management to understand its importance, because the business case for it is probably far more important that, for the company than they will understand, because there's so many companies where they do not, literally no one in the C staff, okay, by that I mean chief executive officer, the chief financial officer, then none of them seem to understand that giving developers time to write test suites will save the company huge amounts of downtime, okay, whether it's in just rigging departments or the whole pipeline department. But generally, IT should never be running with 0% coverage. It is possibly the worst thing that the worst way to run a company. Now, that is a full stop statement. There is no situation within a technical discipline where you should not test your code. It is basically just waiting, means you're waiting for errors to happen, and you're making life harder for your developers. So testing in Python involves creating automated tests to verify that your code is working correctly. In Maya, you can use Python's built-in unit test module to create tests for your scripts. And here are some simple steps to create and run tests in Maya. So let's create a test script and create a new Python script in Maya and import the unit test module. Actually, no, we'll keep this all in Maya actually, and then we can we'll create a new test class that inherits from unit test .test case, and inside the test class we will write one or two test methods to verify the behavior of our code. Okay, now using the magic of editing, I am going to fast forward this whole section. Okay. All right. Cool. So you'll see here what we've got. We've got import unit test. Okay, and now there are various different testing modules that you can download, that you can install, but unit test, it literally does everything you need. Okay, I don't think there's very many circumstances within rigging, especially, you'll need more than unit test. Okay, so let's press Control and Enter over there. Now, what have we got here? We've got our test sphere, which is essentially a class which is taking the argument of unit test.test case. So we're essentially using class inheritance to give ourselves a class with a huge amount of functionality from the unit test module we've imported. We've got 4 functions down here. Let's have a quick look at what they do. So we're defining setup, tear down, and then we're doing test sphere created and test sphere deleted. See what I mean? Tests generally, they should be small. They should be very clear. Okay, unit tests anyway. You can write longer tests if they're integration tests, because they'll be testing larger subsets of functionality. But we're talking about unit tests here specifically, because these are your bread and butter. So when you run the tests, the unit test module will automatically discover the test methods and run them. Anything with the prefix of test underscore will be run. If any tests fail, unit test will print out an error message with the details about the failure. In this example, setup creates a string sphere name, and then it is used by both test methods in the creating of a polysphere. Now, tear down, it then deletes the sphere name object, which this is the name that will be found in Maya, after each test, if it exists, we should say. So we're doing a Maya check here. So Maya, calling the Maya framework, and we're saying, well, Maya object exists. Okay, if it exists, then yeah, delete it. Okay, so we've got 2 things that are happening here at the beginning and the end of each test. So every test that we write, we will set up and then we will tear down. We should therefore keep a nice clean scene for each test that is running, and then there can be no side effects between tests. So we could write 20, 30 of these. Let's say you've got a few functions that are creating geometries, that they are testing geometries, then, or they are, doing certain functionality. They are removing edges, they are adding edges, they are adding edge loops. Let's say they are making items symmetrical. They're checking if they're symmetrical. Maybe that's where you can set up and tear down. You might want to make sure that you have the same model to test with every time. So you can import that model or even build it, depending on what data you have within your library. And then after it, you can just tear it down, delete it, make sure then for the next test, you can import a brand new one. So to run all of these within a module outside of Maya, you would essentially save these to a .py file, and you would save if main, if name equals, or is using our equality operator, if name is equal to main, then run unit test.main. And what this is going to do is search for any test setup. So test, again, it's searching for any classes with test, at the beginning, and it is going to run those, within this folder, or within this module, sorry. So let's go into that a little bit more in depth. So when the interpreter runs a module, so let's say we've saved this as a .py, the magic method, the __ name variable, will be set as main. So if we run this within this screen, wait, something's happened. Let me just scroll down. Let's have a little look. So actually, no, this is run perfectly. So 2 tests ran in 0.8 seconds, and they were okay. We'll see we've got 2 tests. These are the dots that run through. So if you have 200 tests, these are going to be dots going all across, and they run. Every time a test is run, you add another dot. And for every failure you get an F. So you know exactly where they are. And then you get the output below. So that was us running the code within that window. So name equals main, because we're running it from this module. But if the code being imported from this module is from another module, then the name main, or the name will not be main, it will be that of the other module that we are importing it with. So that then means that this test won't be run. These are only going to be run when specifically called. So let's analyze the test results again. Let's go back to these. So after the tests are finished running, you can analyze the results to determine if your code is working correctly. So like we just said. All right, we've got a system exit. But this actually isn't an error here from what we have run. But what we have run is 2 tests that have run correctly here, and they've both passed correctly. We're going to rewrite this in the future so that we actually print out a lot more information, because the default isn't brilliant, but that can be appended like everything else in Python. And we can actually give ourselves a huge amount more information. So once you've analyzed your results, if all your tests pass, then your code is likely to be working as expected if your test cases are written correctly. If your tests fail, then you'll know where to investigate. So let's make an error somewhere. Let's remove our delete, or let's actually comment out our delete. So let's comment out that code, because now we are actually trying to assert that we have deleted this with the test sphere deleted. But now if I stop deleting the sphere, this assertion will be incorrect. Essentially, it will not, it does exist. So this will be asserting the wrong thing. So let's run this. But you see here, now that we've run, I should actually give them a clean window, sorry. Perfect. So 2 tests ran, and we've got 1 failure. And here we go. See what I was saying about the F? We've got 1 dot for a pass and an F for a fail. So we've been given the exact function that has failed, and we then get a trace back. So true is not false, which is what we said. We were deleting this, and then we're using our object exists. So we're asking, does this object exist? And actually it does, because we haven't deleted it. So this is true. This is going to return true. And what we're actually checking for here is that we are asserting false. So we know that this is now, it's not worked. Something has not gone right. So we need to go back and we need to go, yes, I do need to delete that. I've accidentally, left my comment in. And then our test will pass. So again, our test cases have worked. And then applying this to functionality, you would essentially just import whatever module you have made, test it, whatever's happening with test cases, and then check for them after and before. As we go through this project, we'll be trying to set up testing classes, testing for the classes and for the modules that we have for the code as we go. As this is not commonly done in rigging or even in many studios, like I said, that I've worked in, only the very biggest studios seem to do this or make time for it, which I can never understand because as a smaller company, your margins are smaller and the cost to your company is greater, I think, therefore with issues. So I think that obviously with one or two lines like this, it's just nonsense, just not writing tests. Anyway, that's me. We can talk about this further on in the comments if you like to pester me, because I do love testing. It is just a beautiful way of essentially documenting your code about what is going on and what is happening. Well-written tests will essentially say what the assertion is of your code, what is meant to happen. If I'm building a polysphere, I want to delete the polysphere, and then I want to assert that that is happening. And so I would generally go with the suffix of test underscore, which would then be the test in our class, and then I would name our module, and then I would do underscore of what the behavior is that I'm expecting. That is a nice kind of way for us to kind of read through our tests and be able to see easily what is happening. Let's have a little touch on now the unit test methods. So we've got assert true and assert false. So these are essentially the self-dot methods that we've inherited from our test case, which again, we are using class inheritance for, but it gives us these really powerful little methods here that give us just a way of kind of checking expressions. So we are now asserting that things are true, which with Maya, we can check if an object exists, which if we're creating it, we can say, wait, does this object exist? So assert that this is true. And if this responds with true, then our test passes. If our test fails, if we assert something is false, okay, we're essentially checking here. We've created a sphere, we've deleted it. So does this exist now? No, it doesn't. It's false. So we're asserting that this doesn't exist. We are asserting truths within our with our functions. Now, obviously, there are a lot of these, and I have written a list for you within the document for you to download after. But these are gorgeous methods, and these are literally you will learn to love these because you won't get errors in the future. You can write the most complicated rigging system in the world, but if every time you change something or you update it, something breaks, then what's the point? Because you're going to pull your hair out, okay, and stress yourself out. I can quite safely say this isn't a stressful job for me as it is for a lot of people. Some people say that it's terrifying rigging, and like it scares them. And I've met riggers that have said it's the most stressful job that they could have imagined. And it was, well, yeah, it can be, but not if you code everything. If you literally put everything into code, you've seen me. I'm like, my typing is terrible, especially when I have to type, read my notes, and talk to you guys. My typing goes to pot. So I make errors, especially when I'm then thinking 4 or 5 steps ahead and I'm typing, and we all make errors. It's just done. My brain goes off faster than my fingers can type sometimes, and that's fine. But that's where coding's great. You find the errors, you fix them. But the whole point of it making errors is that you know how to deal with it. And I know the best way to deal with it is by catching them and writing code to catch them. So let's have a look. We've already just looked at assert true and assert false. So these take an expression, and if the expression is true or false, you can assert that. We've got assert is none. So if something returns none, then that's true. So assert is not none. So if this can be literally, so everything other than none is now going to be asserted. So 1, 2, a string. Okay, anything that is not the none type will be assert equal. So again, takes an A and a B argument. Assert not equal, assert in. So again, assert is the word Bob in the string Bobtastic. Check that. Let's say we want to check is a joint within a joint chain. Yes. If we want to say maybe is when we've imported a reference, is now the reference when we are using our remove reference function, is it now not in the scene? Assert this. Okay, and if it's not, great. We have our remove reference script is working. Assert is, okay. Let's say we've got a rename function within our class. Is this name now this? Assert is not. Is this object named this? Assert it isn't. Okay, we've just changed it. It shouldn't be named this anymore. Is an instance of. So we've just created a DAG object. Is this sphere we've just created as a DAG object? Is this an instance of that DAG which we put here? Almost equal. And in all fairness, I've not actually used this one. I'll have to read more into this. But again, I would recommend searching it. I'm assuming that you can give a parameter as well. So, but assert greater, assert equal, assert greater and equal, assert less than equal. Again, very obvious, but these are, I pretty much have used all of these, except for almost equal and almost not equal. These are two which I'm going to have to look into actually. But these are amazing assertions that you can essentially make within Python and testing. So let's start as we mean to go on, and I'm going to try and teach you to write these tests as we go through our next series of lectures and tutorials, which are going to get more and more awesome as we go through, guys. Great. So let's look at some common errors now. Okay, all of these will be available to you within the notes, but essentially you just use them down here. So we go self.assert equal, assert is not equal, and you use them that way. So you can just assert whatever output. If you're creating a length of a spline and you just want to check is it equal to whatever else you've just created at the same time to make sure they're equal with the same methodologies, yeah, you can use assert is equal. So you'll see these test methods are amazing at testing your scripts and telling you if they're working. All right, so please use them. Let's have a look at some common errors. Testing the wrong thing. I mean, definitely, again, we've all done this at some point. If you've written code for long enough, you will have done this. It's just something, again, will happen when you're tired. It'll happen when you're new. It'll just happen. Okay, but one common error is just writing a test that verifies the wrong behavior. You might be wanting to test that a sphere is named something, but you might accidentally test that it's true. But testing something's true isn't testing that it is the same as testing is equal to something, because truth with a string just means that the string has to have any kind of data input into it. Okay, as we've checked with our B and OOL, our bool, open parentheses. Okay, we can just see, well, if we type in bool, the Python functionality, if we have a string with a name, that's true. So just make sure that you're testing for the right thing. Read through your tests and check them, and get someone else to check them. If you're new to tests and you've got a senior or someone who's written tests before, ask them to read through your tests and say what they like, they don't like, or even hell, send them to me. I will read your tests. I don't mind. I really don't mind actually reading code. I find it fascinating. You always see some beautiful things in people's code. And I can probably just give you a few lines of say, you know, this is a good thing to do. This is a bad thing to do. So that was one. Testing the wrong thing. Okay. Poorly written test code. There's kind of no excuse for this. You should just take the time. It's a common error, but writing test code that is difficult to read and understand, it just can make it harder to identify the issues with the test or the code being tested. To avoid this, it's important to write test code that is clean, concise, easy to read, and short. Try not to write such big tests that, you know, end up testing 7 or 8 things. It's literally no point, and it's kind of silly because then you'll be having one test that breaks and one of your tests will break and you'll have to fix quite a few things. Just break them into smaller sections. Smaller chunks are always easier to work with. Handling exceptions. Okay, a common error in testing is to not properly handle the exceptions that may be raised during the test. If an exception is raised and not handled properly, it can cause the test to fail, even if the underlying code is working correctly. So to do this, just make sure that you put your try except blocks in to handle exceptions, or that you raise errors if certain parameters are not followed. So you've just got to make sure essentially that whatever happens, that you are checking whether raises, that you're checking that code runs at both the best kind of times and the worst times. So you want to test that if a code is going to run with the right parameters set, you know, as we've said in the past with our control that copies its shape over to other controls. So, okay, does this fail? You want to assert that this fails if only one argument is passed. or only one control. You want to then assert that it passes if the control, that is the driver, doesn't have a shape. Okay, you want to make sure you test for all these things that can go wrong and check that they are either exceptions that are handled within the function that you are testing, and that they are tested correctly. So not testing edge cases. So yes, this is the one. Another common error in testing is not testing the edge cases, such as boundary conditions or unexpected input. This can lead to bugs in code that will manifest in random scenarios. So to avoid this, it's important to design tests that cover a range of inputs and scenarios, including edge cases. Just remember, if you've got user-facing tools that are going to be used by production members. I mean, I've worked between rigging and pipeline, and I don't mind working in pipeline. I prefer rigging, but I've made tools that non-technical people will use, that maybe have come from an animation background, or even maybe just, or maybe I don't know, very much more an artistic background. So they don't really use Maya very much. If you're handing them a tool that then is a scheduling tool, that has very specific ways it needs to be run, then you need to make sure that that is handled within the script. Because if you're asking for an input for a certain parameter within a function, but then that user gives you 2 or 3 inputs, then maybe they use some incorrect characters that you weren't expecting, and they aren't accepted by the tool that you're using. Then these are all going to throw your script. They're all going to break it. So you've got to be creative. You've got to think about all the things that can go wrong. What can go wrong in the script, and are you catching it then within the script, raising an error and telling the user what they need to do correctly? And obviously, you then want to make sure that that is not then going through to any function you have and causing any negative effects. So testing implementation instead of behavior. So finally, a common error in testing is testing the implementation of the code instead of testing its behavior. So this can happen when the test code is too tightly coupled to the implementation details of the code being tested. To avoid this, it's important to write tests that verify the intended behavior of the code rather than its implemented details. Okay. So yeah, context is key essentially with everything that you're doing. All right, now hopefully that made perfect sense to you. Okay, if not, please feel free to watch again. Please go check some resources on testing, on debugging, because it is going to be one of the things that initially, especially when you start out, will probably be the hardest thing for you to get your head around, because you will make a lot of errors and it will be difficult. But just remember to ask people for help, and talk to people, and I'm sure that they will be very willing to give you their time and their help. Okay, if you ask nicely. And and you spend the time as well to try and understand what you think the error might be. Don't just not bother to look at it and then go on Stack Overflow and essentially just post your problem and say, can somebody help me with this? If you haven't even bothered to say what it is, try and then say the context of what you're doing, why you think it's breaking, and why you're confused about this scenario. Okay, people are a lot more willing on Stack Overflow to help you, or even other developers in your team will be more willing to help you if you've tried to fix it yourself. If you don't try, then it's literally just, you're getting other people to do your work for you. So, all right, amazing work, everybody. Okay, this was possibly one of the more difficult lectures that we're going to go into, but also one of the most amazing ones, and most important, we should say, definitely. So being aware of these common errors and writing better code that is more effectively verified will help the intended behavior of your code in Python. So just, be aware of that. So in this video, we have learned about debugging, we've learned about testing, and we've learned about some common errors associated with those. Congratulations, well done. And I look forward to talking to you in the next module about PEP 8 and best practices. It's going to be another very important module, or another important lecture. But yeah, thank you so much for listening. And that concludes most of, I think, the hands-on section of our Python crash course. But I look forward to seeing you on our next section.